Dear students, today topic is NAND SR Latch. In previous video, we discussed the NOR SR Latch. So in both NAND and NOR SR Latch, the only difference is gate we use to NAND means then it is a NAND SR Latch. If the gate used in a NOR gate, then it is a NOR SR Latch. We know that latch is a cross coupling of two gates. These two gates are NAND, then it's a NAND SR Latch. And this is the NAND truth table. Okay, we know the truth table of NAND gate. Both inputs are 0, output is 1. 0, 1 combination, output 1, 1, 0, 1, 1, 1, 0. As we know that NAND truth table, right? So from this truth table, we can clearly say that any one of the input is 0. Any one of the input is 0. The output is high, logic 1, right? Let's see the operation of NAND SR latch in the following three cases, right? Case 1, let us assume initially S is equal to 0 and R equal to 1. So first we assume S is equal to 0, R equal to 1. So according to this truth table, NAND truth table, any one input is 0, the output is logic 1. So here one of the input is 0. So the output of this NAND gate is 1, which means Q equal to 1, right? Q1, which is cross coupled to the input of second gate, and second gate another input is 1. 1, 1 pair produce the 0 output. So Q bar is 0, right? This is the present state. Next we apply the another set of input, right? So in this state the output is Q equal to 1, Q bar is complementary. For changing the input state from 0 to 1, then this output can be considered as a passed output, right? So S is equal to 1, R equal to 1. In this case, let's take S is equal to 1, R equal to 1, right? Then the previous output Q equal to 1. Q equal to 1. The output of this gate is 1, 1 combination is 0. So Q bar is 0. This Q bar value is fed back to the input of first gate. So first gate input is 1 and 0. So 1, 0 combination provide the Q value is 1. So Q value is 1, right? So in this case, S is equal to 1, R equal to 1. The present output will be the same as the previous output, right? Previously 1, present output also 1. Here Q bar 0, Q bar equal to 0, right? This is the case 1. Let's consider the case 2, S equal to 1, R equal to 0, right? S equal to 1, R equal to 0. According to the NAND truth table, any one input is 0, the output is logic 1. So Q bar value is 1. So here Q bar value is 1, which is fed back to the first gate. So 1, 1 combination provide the Q0, right? So Q0. Now the next state is changes from this S equal to 1 to 1 and R is changes from 0 to 1. In this state, the passed output is this one, right? So S equal to 1, R equal to 1. The passed output of Q is 0, right? So 0, 1 pair provides the output is 1. That is Q bar is 1. And for the first gate, the one input is 1 and the feedback input is also 1. So 1, 1 will provide the output is Q equal to 0. So Q equal to 0. So in this case also, both input are equal to 1. Then the next state will be the same as that of previous state. So 0 na 0, 1 means 1, right? According to these two cases, if both input are 1, then the next state will be the previous state, which means no change. And here S equal to 0, R equal to 1, then next state is Q equal to 1, which means reset state. S equal to 0, R equal to 1, then Q1 is 1. And S equal to 1, R equal to 0, then the next state is reset state, right? Then case 3. In case 3, both inputs are 0. S is equal to 0, R equal to 0. So NAND gate truth table, one input is 0 means the output is 1. So both outputs are 1 1 because this input is also 0, this input is 0. So output of both NAND gate is 1, which means Q equal to 1, Q bar 1. But which is not possible because the latch always provide the Q and Q bar is complementary, right? If 1 means Q bar is 0. If Q equal to 0 means Q bar 1. That is the logic. But here both outputs are 1. So which is called as the invalid state. If I am changing again S is equal to 0. Sorry, S equal to 1 and R equal to 1. Right? So in this case, what will be the Q and Q bar? Because the previous output is 1. Right? If S equal to 1, R equal to 1. Both are 1. And Q value is 1. 1 1 output is 0. Q bar is 0. And this 0 is given to the here. And one more input is 1. So 1 0 combination is 1. Q is 1. Right? So here Q is 1. Q bar is 0. Right? Which also not satisfied for the condition of both input is 1. We'll get the previous output, but here we are not get the previous output, right? So for the input combination S equal to 0, R equal to 0, which provide the invalid state. So from these three cases, we can form the truth table of NAND SR latch. So for 0 0 inputs, the output will be what? The next state will be the invalid state. Right? Which means X. Here also 0 0. Invalid state. Whether the Qn is 0 or 1 is not a problem. If both inputs are 0, our next state is a invalid state according to the case 3, right? And the next set of input is 0 1. 0 1 combination give the Q value is 1, right? Q values, which means next state is 1. So 0 1 combination, the next state is 1. The Qn may be 0 or 1, not a problem. If 0 1 input combination provide the next state is set state, right? And the next case is 1 0. So 1 0 case is nothing but our second case 1 0. So 1 0 combination, the next state will be the 0. So for 1 0 combination, our next state will be the 0. So 1 0 combination, our next state will be the 0. Right? Whether the 0 Qn is 0 1 is not a problem. And the last set is 1 1. For 1 1 condition, what will be the next state? Which is same as that previous state. Right? Which is same as that previous state. So here 1 1 condition, the next state is the same as the previous state. So previous state is 0. Here also 1 1. The next state is same as the previous state. So previous state is 1. Right? So this is the observations we measured from these three cases. So from this observations table, we can finally make it as S R and next state Qn plus 1. Right? This is input, is output. So 0 0 combination, 0 1 combination, 1 0 1 1. So 0 0 combination, what happened? Invalid state, which means X. It is a invalid state or forbidden state. And 0 1 combination, 0 1 combination will provide the output is 1. Right? So 1. So 1 means it's a set state. And 1 0 combinations. 1 0 combinations will give the 0 0, which means reset state. It is a reset state. And 1 1 combination will provide the Qn, that is previous state. So we can say that it is a Qn, no change state, right? So this is the truth table of NAND SR latch. So this truth table is very important for the next upcoming videos like types of flip-flops, right? Is it clear?